Okay. Where is it continuous? Kari?
From 0 to 1, 1 to 2, and 2 to 4.
0 to 1, 1 to 2, and 2 to 4. What kind of square around, what are we doing?
Including 0, not including, including 1. Well, yeah,
Square around on this one.
square. And then round.
You guys agree with this? I see some yes, some no. Okay. This together means include, which means it is continuous at 1, which it's not, so we need to do that. You're right that it is in the domain, but it's not continuous at x equals 1. By putting a square bracket here means it would be. And like formalisms, today we will, yeah, I would include these because they are endpoints. But technically, to be continuous, the limit from the left has to equal the limit from the right. And it has to equal the function at that point. And ends don't have the other side, but today we're gonna describe and define that as like, well, if it is just the end, we're gonna say it's okay. So where is it discontinuous? Discontinuous at 1 and 2, which she identified there. Julia, what's the domain?
From 0 to 4.
0 to 4, inclusive, mix and match.
Yeah, inclusive.
So despite the discontinuities, there is a y value described and defined for every single x in 0 to 4. Sebastian, what's the range?
Oh, the range, it's 0 not inclusive all the way up to 2, I think.
Inclusive or?
Inclusive.
So round bracket on the 0 up to 2 square bracket. Good. Okay. Definition of continuity. There it is. It's continuous at C if the limit at C is equal to the function at C. And if I don't tell you what side, the limit of C, that means both directions need to come in at the same spot. Alright, so at a left end point, left end point, over here. Says if we're coming at A from the right, and it goes to where the function is expected to be, then we're gonna say it's continuous at the end point. So that make sense? It's not a big deal, it's just getting you guys into how super picky the AP can be. Ooh, interesting. Evan, what do you think the conditions need to be for the limit for there to be continuousness at the right endpoint? Same thing, but coming from the left. It's part of it. I mean, woo. All right. Flavors of discontinuities. You know these, right? Removable is where, yeah, just like this one I see as a drawbridge stuck open. We're down on the Beltway around Virginia, they have a drawbridge. I was very late to a presentation to NASA because the drawbridge was stuck open for 3 hours. Then it could also be the bridge is washed downstream, like it could be defined somewhere else, the dot, but just not where you want it. So that one's removable. Limit descriptions of this. As we approach C, the function is not where we want it to be. The limit goes somewhere that isn't where the dot is. If you are ever asked to like give limits to prove that it's removable, you need this part to say, and the function isn't where we want it to be or where we expected it to be. Because we just said the continuity is the limit of the function at that spot is going to where that spot is supposed to be. And a jump. Is where the limit from the left and the right go to different numbers. And it's got an infinite for asymptotic discontinuity. When either side goes to infinity. Okay, so this one at D, what kind of discontinuity? Infinite? Because who's gonna win, infinity or 1? Infinity wins. Okay. So those are the ones you're responsible for, and can I clear this? And I always show this, and I'm like, it never shows up, never happens. It has recently. So, that function, what was that function look like? I had to graph it. A square rooty looking thing. I do that, what, we do not teach conic sections, I would say at all, but we don't do it very well. It is introduced to you and dropped in geometry. Had that in like, what, 4th grade? Yeah. What shape is that? Is it a parabola, is it a circle?
Yeah,
What? Hyperbola? Okay, how do you know? What are you looking for?
in mine, it's the circles added, right?
Okay, circle it would be a plus. So if it was a plus, then it's a circle centered at the origin with a radius of 2. If only one of the things is squared, it's some kind of parabola. If I had something like that, it's an ellipse, it's a wonky, lopsided circle. But you're right, that one's a subtraction, so it's a hyperbola. Okay. Hyperbola. Well, is it that kind of hyperbola or that kind of hyperbola? Left, right, or up, down? Alex, which one? Why do you know that? Okay, let's think of it this way. Let's see, when y is 0, x is plus or minus 2. When x is 0, y squared is something negative, it's imaginary, it's not gonna cross the y-axis. So you're right, it's a left-right. But going back to the original question, the function is only the positive part. So it look like, right, little bug antennas. Clearly discontinuous. Is it removable? No. Is it a jump? I mean, it's a horizontal jump. When we talk about jump discontinuity, we mean one thing is directly on top of the other. So it's not jump, and it's not infinite, so it's not any of the 3 we just talked about. We used to make up names for this. But it's a domain discontinuity, but that, there's a chasm there. And it's just because those numbers aren't in the domain. We can't do those square roots of the negatives. It's just very rare if this comes up, but if it does, you'll be like, ha, I know what it is. Make sense, George? All right. Try this problem, and I apologize for the crappy wording, but it's what the textbook writes these questions. factor, and the problem child in the bottom has a problem child that mitigates it up top. It's a removable discontinuity at x equals 2. It's not removed, 2 is still not in the domain, which is why your textbook would ask for a piecewise function. So everything that's not 2, that's a good answer. When it is 2, what do we want the function to be? 5. So, the Joey rule, not sure I went off on Joey in this class. The Joey rule, he was a minimalist. He's like, there, we're good. It's like, yeah, but Joey, it did say give a piecewise function, that's not one. The actual instructions said he was pretty irritated, which I thought was fair play. All right. To expose you to what multiple choice is like in calculus. Think about it, talk it over with the person next to you. This is tricky. Can we eliminate any? Can we pick any? Any line of attack? It has to be what? D? Why does it have to be D? Okay, all right, so. Telly's saying, they told me this coordinate is on the function. They told me that coordinate is on the function. And then the keyword that he's putting in there, they told me it's continuous. So I have to connect the dots without picking up my finger because that's what continuous means. I could do that. So is it A? Does it have to go through 0, 0? No, I could be like, ah. So it's not A. We're gonna skip B for a second. Okay, this is saying between, does the f of x is the x value or the y value? Y value, does the y value have to stay between -1 and 3? No, the blue thing I just drew clearly, not that. Does the function have to have a y value of 1 for at least one x value between -3 and +6? Yes. For about 5 minutes last year, there was a theorem that we told you about. There was like elevator going up and down, and there was this Ferris wheel going around, and was there some point that Johnny in the elevator was the same height as Kathy in the Ferris wheel? And there was, because, oh, the elevator is going down, is the Ferris wheel going up? A really dumb question. But, anybody remember the name of the theorem? I'll tell you in a second. Does the y value have to be 0 for at least one x value between -1 and 3? I suffer from concept dyslexia. They are being mean, they picked the Y values, and I was like, oh, they're trying to see if they can confuse you. So, they shrunk the space. Once we learn mean value theorem, this one is, you're gonna pick this one, but you know better. The theorem that I'm referring to from the past is intermediate value theorem, and it's exactly what Vitaly said. If the function is continuous and it had to go from height of A to height of B, you need to go through all of those heights between the two. You might go past them, but you're guaranteed to hit every single one in between. So they'll ask you stuff in various ways, but, if I tell you the function's continuous, f of -3 is 18, and f of 5 is -1, does the function have to hit 0? Somewhere between -3 and 5?
Yeah.
Yeah. So, I've seen multiple choice questions that they ask this in ways that you need to actually do some calculations to see, wait, it changed sign from here to there, because it changed sign, it had to hit 0. And the reason is intermediate value theorem. Questions? Issues? Try that problem, and then I'll show you the irritating notation that they want to see. Answer it how you would answer it, and then I'll show you what they want. A little early for P studies to be doing that. You guys don't take P studies class, because that's off the first period, if they even still have it. But they would go out to the corner and be like, honk if you're for peace. Like, you feel like a jerk if you don't. You guys taking tests first period and people are going, you guys are like, I'm gonna kill them. Doesn't make you very peaceful at all. Apologize in advance, just warning you it's coming. Adrian, apologize. Got an answer? Or which answer? C equals 5? Okay. So, I imagine what you guys did was this. This might even be more work than you showed. They're not gonna like that. So, definition of continuity. As we approach 1 from the left, this piece is the left, needs to equal the function at 1, which needs to equal the function from the right, which is this piece. Gross. This is proving the continuity and how to calculate, plugging in the 1. Both of these are the same equation, so 5 equals 1 squared times c. They want to see a little beefy justification to it. So just a heads up. All right, so that's continuity and the different kinds of discontinuities. You guys remember those and no problems? Okay. So then, completely different. Here's your next thought challenge. Non-curricular math task. So I want you guys to come up with ways to create the numbers 1 to 20 using exactly 4 4s and any math operation you want. So if you come up with one, like 0 wasn't in there, but I'll show you, look, I made 0 by saying 4 plus 4 minus 4 minus 4, I got 0. So try it. And if you come up with one, come and put it up. And if there's already one there, that's okay. You can be like, oh, I found another way to find one. Or I found another way to. Go ahead. You got one? Go for it. And more than one person can write on the board at once. It can handle 10 fingers. You can, if you had a different one, or is it that exactly what you were?
No, I was thinking about like something else. Wait.
Ooh. So last year's class was here at lunch to help people. You gotta use 4 4s, those are only 2. And you used a 0. That's cheating. So that's 4 times 4 minus 4. So 16 minus 4 is 12, divided by 4 is 3. Okay. Okay. And there are multiple ways to get at these. So if you guys want to put up one that's already been solved, but you have a different way. Hard ones are the prime numbers. fourth root of 4 times the fourth root of 4. Okay.
That's crazy.
Yep. 1 plus 2 plus 4 is 7. Seriously, we can't get 4? Just 4? Roman, draw your kayak thing up here. Draw your kayak thing. You keep asking me about it. I can't look at it on my tiny coach's damn phone. Your
Oh, yeah.
heavy. 10, 11, 13. Okay, that's a minus, okay. I thought it was, so 16 minus 4 is 12, minus square root of 4, 10. So what was your? But I mean, four of them left. Anybody see?
We switched.
Hang on, let me know. So I was wondering if people were gonna get to the factorial. Someone just put a factorial, or was going to put a factorial up. What is 4 factorial? 24. Okay, 18, 4 times 4, 16, 20, 20 minus the square root of 4 is 18, okay? 4 factorial divided by the square root of 4 is 12, minus 4 divided by 4 is 11, very clever. And this is 13, oh, fighting over it. Amelia, you can put one up on the side.
I think he might write the same thing. Yeah.
So is that 4 factorial?
Yeah,
What the?
yeah.
Let me see.
4 factorial divided by the square root of 4, so again, we get 12 plus 4 divided by 4.
Yeah.
So, very much like 10, instead of subtracting it, add it. Okay. There are lots of variations of this problem. Only using 6s, we got up to like 70. Any number of 6s, but you had to use just 6s to go from 1 on up. Let me tell you, getting the prime numbers and stuff, that was kind of weird, kind of hard. Yes. Any other creative answers? Okay. And all of these worked, right? I was checking them as they went up, but I might have missed them. So I think they all work. Yeah. Your scintillating homework of the weekend is the next day of stuff, and I'll bring it up. And if this is too hard to see, there are textbooks in the back, in the cabinets behind Evan.